to say that we are headed south, very far south. We have already traveled to the tip of South America, and we're now sailing even further southward, across the area of the southern seas known as Drake's Passage.
This is a great place to point out an important difference between the North and South polar regions. The Arctic, at the far north of our globe, consists of an ocean of water that is almost completely surrounded by land. North America, Greenland, Iceland, Eurasia. By contrast, the Antarctic, at the far south of our globe, is a continent of land that is completely surrounded by water.
Another perspective on that same geography comes when we focus on our oceans. Land masses make up the northern edge of all three of our world's great oceans, but those same three oceans are open at the south.
In this region, strong winds blow almost constantly from the west, and let me tell you, these winds are strong. And there is a very important consequence of the pressure of this wind pushing relentlessly on the water. The result is that the water also flows from west to east. This is called the Antarctic Circumpolar Current, and it stretches for more than 20,000 kilometers along the entire coast of Antarctica. This current is very wide and very deep. So even though the rate of flow is modest, it moves an incredible 135 million cubic meters of water every second. That means it carries more than 100 times the volume of water moving in all of the world's rivers combined.
That enormous volume of water, constantly flowing from west to east, is the main reason for the similarities of salinity and other properties of our oceans. Some of the waters of the Pacific, the Atlantic, and the Indian Oceans are constantly being carried from one basin to another down here at the bottom of the globe. Underwater, there are also other patterns that add a considerable level of complexity. Cold water tends to sink because of its greater density. So water that is chilled in the region around Antarctica tends to move slowly downward, and warmer water from further north is very gradually drawn in to replace it. The result is a gigantic conveyor belt that carries heat away from lower latitudes and cold away from higher latitudes. Overall, this has a unique role in the Earth's climate. The polar regions are less cold than they would otherwise be because of the flow of warm water moving toward them at the surface, and the equatorial regions are less warm because of the cold water rising upward from below.
In any event, enduring those very strong winds and rolling seas was definitely worth it. That is because there is nothing that compares to the thrill of reaching Antarctica itself, an entire continent that is almost completely covered in snow and ice. Most of the ice down here originates as snow. So does fresh water, frozen fresh water. Most people are surprised to learn that it really does not snow very much in Antarctica, only about 50 millimeters per year, water equivalent. So in that sense, it's a desert, comparable to the Sahara in terms of annual precipitation. But it is so cold that the snow that does fall almost never melts. So over the course of hundreds of thousands of years, those small amounts of annual snowfall have gradually sequestered an enormous amount of the planet's H2O. Each new layer of snow falls on top of the one before it. And ever so gradually, those snow layers collapse under the weight of the ones above them. The result is that Antarctica is covered by very large ice sheets.
Said that the words very large does not really do them justice. The Antarctic ice sheets are immense. They encompass about 14 million square kilometers. That is an area about as large as all of Europe. They average more than 2,000 meters thick.
There is so much ice down here, approximately 75% of all the world's fresh water is within these immense Antarctic ice sheets. On a large scale, gravity causes most Antarctic ice to flow across the continental bedrock, in a radial fashion from the interior of Antarctica out towards the sea. As it moves across some portions of the continent, the ice forms huge valley glaciers that push through gaps in Antarctic mountain ranges. It takes many thousands of years, and the ice is often distorted spectacularly as it flows. But the ice eventually reaches the end of those valleys, and there it periodically breaks off to fall in pieces into the sea. This is referred to as the process of glacial calving. This is the origin of many of the irregularly shaped icebergs that are so common in Antarctic waters. Some of the largest of these icebergs resemble small mountains, but ones that can be quite unstable. As they float, the rate of melting is much greater below the surface, where the ice is in contact with the relatively warm water, than it is where the ice remains chilled by the cold air above. As a result, some icebergs reach a point where there is more ice above the surface than below. As this melting progresses, the center of gravity of the iceberg gradually moves higher and higher, until the entire enormous structure suddenly tips over. Sailors refer to such icebergs as rollers, and they represent a significant danger to anyone or anything in their vicinity. Just look at the enormous amount of kinetic energy being displayed as the thousands of tons of ice go into motion. This is an object approximately equal in size and mass to a skyscraper, and it is rotating 180 degrees in just a few seconds. In any event, once they are in the water like this, over time, most icebergs break up into smaller and smaller pieces. Over our shoulder is one of the smallest types of icebergs. It's known as a growler.
It's the most dangerous for ships and yachts because it only sits 1 meter above sea level and it sits right on the waterline. Nevertheless, despite its apparent small size, this underwater view reminds us that most of any floating piece of ice is under the surface. So there is still more than a ton of solid material in this little iceberg. Still, even those little icebergs become even littler, and the action of wind often pushes them together.
In the end, these small pieces end up in fields known as brash ice. And the relative cloudiness, or clarity, of each piece reveals a great deal about its origin, particularly how low or high that section of ice was positioned when it was part of the mile-thick ice sheet. This little piece of brash ice looks white because of the high density of bubbles within it. This means that it is relatively young, and that it fell into the sea from near the top of a glacier.
Whereas this piece appears to be nearly translucent due to the fact that the bubbles have either been compressed or pushed out during formation. That is what happens to the ice at the lower levels of a glacier, due to the tremendous pressure from the weight of all of the ice above it.
And this is a piece of really, really old ice from the bottom of a glacier. It is crystal clear because all of the air has been compressed out of it over thousands of years. But the story of icebergs does not end there. So far, we have been talking about the gigantic valley glaciers that are obliged to force their way through Antarctic mountains. But in many other places, the outward flow of the continental ice sheets is relatively unimpeded. And in those places, when the moving ice reaches the end of the bedrock, it forms enormous ice shelves that float on the sea while still remaining attached to the continent. In some places, these ice shelves extend for many hundreds of kilometers and are more than 300 meters thick. So in total, these floating ice shelves represent thousands of cubic kilometers of frozen water. Yet, despite their immensity, the smooth, gradual process that forms them leaves these ice shelves relatively flat and featureless. Except that they do terminate with dramatic, towering ice cliffs along their edges.
The ice shelves of Antarctica appear to be particularly sensitive to global temperature changes. This is due in large part to the fact that these ice shelves are in contact with ocean water, and due to the fact that ocean temperature directly reflects climate changes.
So, many of the scientists who are tracking climate change have a particular focus on the Antarctic ice shelves. Most computer models that attempt to predict the effects of global warming indicate that the ice sheets that rest on Antarctic bedrock will probably change very slowly. But as we anticipate the coming rise in ocean temperatures, it is predicted that there will be considerable melting of the Antarctic ice shelves.
During the austral summers that bring almost continuous sunlight, so the phytoplankton in the sea blooms in phenomenal numbers. That in turn feeds an enormous food web above it. And more than anything, that is the story of krill.
There are a number of species of krill. All are small crustaceans that consume the phytoplankton in the upper levels of the ocean. They exist down here in almost unimaginable numbers. So much so that krill may well be the most abundant animal life form on Earth. In terms of biomass, there are certainly more total kilograms of krill than total kilograms of humans.
So not surprisingly, there are a phenomenal number of fish that consume krill. And there are huge numbers of birds and other mammals that consume fish. As a consequence, the shoreline of this continent is teeming with fish-eating birds and mammals. And of course, there are also the whales. In the summer, thousands of whales migrate to Antarctic waters in order to feed on krill directly, and also to feed on the fish that are eating krill. Lastly, there is no shortage of predators of the predators. Leopard seals patrol the ice and hunt of fish-eating penguins. And orca whales patrol that same ice at the very top of the food chain. They prey upon penguins, seals, and even the larger whales.
In one way or the other, all of these species are dependent on phytoplankton and krill at the base of this amazingly productive food web.
And now, as we are nearing our time to leave Antarctica, there is something else that is really important for us to say about this place. From our perspectives as students in the Animal Behavior, Ecology, and Conservation program at Canisius College, this place is amazing in every respect.
It is not only the most remote region on our planet, it is the cleanest, most undisturbed wild place you can ever imagine.
This entire continent is more than just unpolluted. It is pristine clean. Its ecology is more than just surviving, it is thriving. This entire Antarctic ecological zone exists with less disturbance by humans than is seen elsewhere on the planet. It is kept this way through a remarkable spirit of international cooperation.
No single nation owns Antarctica, or even any part of it. Ever since the Antarctic Treaty was first signed in 1959, there has been a multi-nation regimen that bans military activity and ensures free access for scientific research. It permits a small amount of highly regulated ecotourism, and for the most part, it manages the use of resources in a responsible fashion. This all serves as a shining example of the best that we can do as humans.